Welcome back to Math 109 Plane Trigonometry. In this video we're going to take a look at the right triangle based definitions of the trig functions. So we're going to start by drawing an angle in the first quadrant. We can only use these right triangle based definitions in the first quadrant. However, later we will talk about ways we can generalize this to any quadrant. So with an angle in standard position, we have one side of the angle on the x-axis, and the other one, we've established this has to be in the first quadrant. So we'll go ahead and call this point xy, which means by our coordinate geometry that down here in the right triangle, that is length x, then this is length y. And we'll go ahead and call the length of the hypotenuse r, as we did in Chapter 1. Well, we recall from Chapter 1 that the sine of theta, which is down here, is equal to y over r. And the cosine of theta is equal to x over r. And finally, tangent of theta is equal to y over x. However, if we take a look at where theta is in our triangle here, we note that y is the length of the opposite side, x is the length of the adjacent side, and r is the length of the hypotenuse. So some of you may recall from some point in high school SOHCAHTOA, which is a convenient way we can remember these right triangle based definitions. This says the sine of theta is equal to the opposite over the hypotenuse. The cosine of theta is equal to adjacent over hypotenuse. And the tangent of theta is equal to the opposite over the adjacent. Well, now what I'm going to do is I'm going to draw another triangle here. So I'm drawing this so that we have the angle theta in standard position. Well, we know that the right angle is 90 degrees. We know this angle is theta. So therefore, this angle here is going to be 90 minus theta, because the angles of the triangle have to add up to 180 degrees. Well, we can now use the right triangle based definitions on that angle. So we'll go ahead and call that y, that x, and that r. Well, let's look at sine first. That's opposite over hypotenuse. So the sine of 90 minus theta is equal to, opposite of the angle 90 minus theta is x. Hypotenuse is still r. Well, that's equal to the cosine of theta. So that's an identity that we have. The idea that the sine of 90 minus theta is equal to the cosine of theta. Likewise, cosine of 90 minus theta. So that'll be for that angle adjacent over hypotenuse. So that's y over r. That's equal to the sine of theta. And we can keep on doing this with all the other ones, and we'll obtain that tangent of 90 minus theta is equal to the cotangent of theta. Likewise, the cotangent of 90 minus theta is equal to the tangent of theta. And the same thing applies with secant and cosecant. Secant of 90 minus theta is equal to the cosecant of theta. And the cosecant of 90 minus theta is equal to the secant of theta. So these are are called the co-function identities. Basically saying that in the first quadrant, you take a function value, the cofunction of that angle's complement will be equal. So that does it for this video. In the next video, we're going to take a look at some of the trig functions on special angles.